Every material has a specific capacity to withstand an applied force which will either stress, subject to tension, or strain, deform it. This capacity or property for some materials is high and for others is low. When the capacity of the material to withstand the applied force is high, the material is said to possess a property called elasticity. Elasticity can be defined as the property of a material to regain its original shape and size after it has been subjected to, or distorted by an external force. So a material is said to be elastic when it possesses this property. That is, it can regain its original shape and size when a force subjecting it to tension and deformation has been removed. There is a law that guides the behavior of materials when they are subjected to an applied force. It is referred to as Hooke's law of elasticity. It states that, provided the elastic limit of an elastic material is not exceeded, the extension, E, of the material is directly proportional to the load or applied force, F. From experimental observation using a spring and different loads of varied masses, a graph of the load is plotted against the extension. There are certain points to note on the graph. The region OE on the graph is called the elastic region. The region EB on the graph is called the plastic region. And the part marked B is called the breaking point. Other points to note from the graph include 1. The proportionality limit marked with P. 2. The elastic limit marked with E. 3. The yield point marked with Y. The elastic limit is the limit of force beyond which the stretched wire does not return to its original length when the stretching force is removed. Hence, an elastic material will only obey Hooke's law of elasticity within the elastic region. That is, to the point of the proportionality limit. And deformity begins to set in towards the elastic limit. Beyond the elastic limit is the plastic region. At this point, the material no longer returns to its original shape and size after the applied force has been removed. The yield point, marked with Y, is the point beyond the elastic limit in which the elastic material has lost or given up all its elasticity or elastic property and has become plastic or non-elastic. At this point, the material begins to rapidly increase in its extension for any slight load applied. When the maximum extension is reached at the breaking point, the material snaps. From Hooke's law, we recall that the force, F, required to stretch or compress an elastic material is directly proportional to the extension, E. Thus, F is equal to K times E, where K is the constant of proportionality called the elastic stiffness, or force constant, or stiffness of the material. It is defined as the force required to give a unit extension. It is measured in newtons per meter. The force, F, can also be given as the weight of the load, which is the product of the mass of the load and the acceleration due to gravity.